Last section on differentiation. These are more word problems. We're going to do every other one. A closed box with a square base is made out of 600 centimeters squared of metal. Find the dimensions of the box so that its volume is a maximum. Find the value of this maximum volume. Okay, so you have a box with a square base. Okay, and the total area, if you count up all 6 sides, is going to be 600 centimeters squared. And we know that the bottom is or the top is a square. So let's say if we were going to write the dimensions of this box, the two sides are going to be x and the height is y. So what is the volume of the box? It would be equal to x squared times y. Now, how can we relate the x and y's to 600 centimeters squared? Well, if we add up the area of each side, so the area of side 1 plus the area of side 2 plus the area of side 3, blah, 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 all the way to the area of side 6. Do you notice that a cube has 6 sides? Okay, so let's say the top and the bottom would be x times x, right? What about the sides? So each of the sides would be x, y, and there's 4 sides. And we just add all those together. So what we end up with is 2x squared plus 4xy. And that is equal to the total area, which is equal to 600. So 600 equals 2x squared plus 4xy. And then we know that the volume is equal to x squared times y, and we're trying to maximize that. So the first thing we need to do is we need to try to write the volume equation with only one variable, either x or y. So we're going to use this constraint equation to express x in terms of y or y in terms of x, whichever one is easier. And I think that what's going to be easier is probably y equals something rather than x equals something, because here I'm just going to show you why. So if I tried to get x by itself, it's a quadratic. It's kind of messy. So, but to get y by itself is not so hard. We're going to subtract negative 2x squared from both sides. We get 600 minus 2x squared equals 4xy. And then we divide both sides by 4x. And this is just algebra, but, you know, not the easiest algebra. Divided by 4x. So y is equal to 600 minus 2x squared divided by 4x. We're going to put it here. Volume equals x squared times 600 minus 2x squared divided by 4x. And then if we want to simplify that, these x's cancel out. So this x cancels out with this x. Oh, not with one of these x's, just the squared, right? And we'll end up with v equals x times 600 minus 2x squared divided by 4. Okay? And it says find the dimensions of the box and then find the maximum volume. And once we get this, then the easiest thing to do is to graph it. So we're going to put this equation in here. We're going to have x, and this time it really is an x, isn't it? X times 600 minus 2x squared divided by 4. You can graph it. Okay, and then we're going to find what is the maximum point. Looks like it's that, right? So we'll do second calc, maximum, which is 4, and then with the left bound, there's the cursor. It was way to the right. Hit enter on the, it's on the left side of the little hill, and then we go to the right side, we hit enter again, then we guess. And then the maximum is x equals 10, y equals 1,000. So the maximum point is going to be 10 comma 1,000, and the 1,000 represents the volume, right? And the 10 represents the x value. So we know that x equals 10, volume equals 1,000. Now we just need to figure out y. Okay, let's see. If we know that, if we take this formula, we have 600 equals 2x squared, and remember x is 10, we already know that, plus 4 times 10 times y. So 600 equals 200 plus 40y. So subtract 200 from both sides, we get 400 equals 40y, and now we know that y is equal to 10. So y is also equal to 10. So we just discovered now that x equals 10 and y equals 10. Y equals 10. Okay, x equals 10 and y equals 10. Those are the dimensions of the maximum volume box that you can make out of 600 centimeters cubed. And the volume is going to be 1,000. Okay, all right. Now we're going to go down to number 11. A tin of soup is made in the shape of a cylinder so that the amount of metal used in making the tin is a minimum. The volume of the tin is 350 centimeter cubed. The radius of the base of the tin is 5. Find the height of the tin. Okay, so it's saying, hey, this radius here, this radius is equal to 5. What is the height? If we know that the volume is 350 centimeters cubed. Okay, so for A. Now to do this, we haven't done the volume section of this book, but you might know how to figure out the volume of a cylinder. It's actually the area of the top of the cylinder, which is pi r squared, for those of you who remember the area of a circle, and you multiply it times the height, which is h. So the volume is equal to pi r squared h, which is equal to 350, right? Is equal to, and then we multiply pi times r squared, which is 5 squared, times h, which we don't know. So let's find out what h is. We can divide both sides by pi 5 squared. And that would be 350 divided by 25 pi is equal to h. So we've just found out what h is equal to. And you might say, hey, there's a variable there, pi. Pi is not a variable, 3.14. So we can actually figure out an exact number for h. Okay, so that's A, right? So A, that's the answer. Now for B, it says, if the radius of the tin is 2 centimeters, find the height of the tin, the height of the tin. So it's this, pretty much the same thing. It's going to be 350 divided by 2 squared h, or 2 squared pi, which is equal to 4 pi, right? So 350 divided by 4 pi. Okay. Now C. Use the volume of the tin to write down the constraint between the radius of the tin and its height. Okay, so pi r squared h is equal to 350. Okay, so this is the constraint they were talking about, because this constraint relates r with h. Pi, remember, is 3.14, 350 is just the number 2. So this is telling that, okay, if r gets bigger, h gets smaller. If h gets bigger, r gets smaller. Now we'll do part 2 of C. Show that the constraint can be written as h equals 350 divided by pi r squared. Now, if you look at this equation, if you divide both sides by pi r squared, then you are going to get exactly what they have there. Okay? Now, number 3. Find an expression A for A, the total surface area of the cylinder, in terms of r only. Total surface area of a cylinder in terms of r only. Okay, so now we're going to say, okay, for part 3, we're going to take the top of the cylinder, and then we're going to unroll the side of the cylinder, and we're going to have the bottom of the cylinder. The top of the cylinder is equal to pi r squared area. Bottom of the cylinder is equal to pi r squared also. And this part is equal to, now these lengths here are equal to the circumference of the top and circumference of the bottom. Well, you might not remember that the circumference of a circle is 2 pi r. So the area of this part is 2 pi r, which is the yellow line here. And then the height, which we'll draw in orange, is h. So these are the 3 quantities you have to add together to get the total area. The total area is equal to 2 pi r squared plus 2 pi r h. Okay, and that is the expression for A. And then it says for 4. Find the dimensions of the tin that minimize the total surface area of the tin. Okay, so we want to find out when A is smallest. Okay, so we know the constraint equation is either h equals 350 divided by pi r squared, or you could also write it as pi r squared h equals 350. Okay. Either way, what we want to do is we want to get rid of either r or h. And it's easier to get rid of h because there's only one h, right? So let's say we'll plug in this number into here. So then we're going to have area equals 2 pi r squared plus 2 pi r. And then here we're going to put 350 divided by pi r squared. And then we're going to cancel out that with that. Cancel out the pi's, and then we end up with area equals 2 pi r squared plus 2 times 350 is 700 divided by r. And now we can use the calculator and figure out when this area is maximized, or minimized, sorry. So we're going to put the equation A equals 2 pi r squared plus 700 divided by r. A is going to be y1. R is going to be x. So we're going to put 2 pi. There's a pi number here. Oh, here it is. Blue or second. There we go. 2 pi. And then r, we're going to put x because there is no r in the calculator. Plus 700 divided by r, which is x. Okay, and then we're going to graph it, and we'll see what it looks like. Wow, it's pretty crazy. Let's try to do the zoom so that we can see everything. Okay, after quite a bit of work, I was able to show this graph in the interesting part of this graph as well as possible. We're looking for the minimum value of the area Since we're interested in the positive region, the minimum value would be here. So then we use the second calc function and we find the minimum. And we're going to find the left bound, this point, compared to the right bound. And it tells us the minimum would be 3.82 for x and 275 for y. So that means that our minimum point is going to be 3.82 and 275. 275 is the area, and 3.82 is r. And it wanted to know and there's the area right there. They wanted to know that. The other thing they wanted to know are the dimensions. So that would be r and h. We only know r so far. The way we find h is we use this equation. So we have h equals 350 divided by pi r, 3.82, squared. So that would be equal to, we'll get out of here, and then we'll do 350 divided by 3.82 squared, and then we divide that by pi. The answer would be 7.63. So the height is equal to 7.63. Okay, so the radius would be 3.82 and the height would be 7.63. Last of all, we're going to do number 15. Okay, a fish tank is to be made in the shape of a cuboid with a rectangular base with a length twice the width. The volume of the tank is fixed at 225 liters. The tank is to be made so that the total length of steel used to make the frame is minimized. Okay, so if the length of the base is 100 centimeters, what is the width? Okay, so that means, let's see, we already know that length is equal to twice the width. So if the length is 100 centimeters, then that means that the width would be 50 centimeters, right? That's the answer to A1. A2. Show that in this case the height of the tank is 45 centimeters. Okay, so in this case we're going to have to use this constraint equation, which is that the volume of the tank is 225 liters, and that's equal to length times width times height. One of the problems we have here is that the length times width times height, each length is in terms of centimeters, and the volume is in terms of liters. Now we have to remember how we relate liters to centimeters. And the way we do that is 1 liter of water is a cube that is 10 centimeters by 10 centimeters by 10 centimeters. So we're going to use that fact to say that 225 liters is actually 1,000 cubic centimeters per liter. So our equation is actually going to be 225,000 centimeter cubed is equal to length times width times height. Okay, so we know that the width is 50, the length is 100, and we know that we have this. So we're going to have 225,000 equals length times width times height. Length is 100, width is 50, and then we have height. So this is equal to 5,000 times height. And then we can divide both sides by 5,000. And that will give us 45 centimeters equals height. Okay, and that was the answer to 2. show that the height of the tank is 45 centimeters. And then find the total length of the steel frame, the length of the steel frame. So the total length of the steel frame, we'll call it S for steel frame, is 4 times L plus 4 times W plus 4 times H, because those would be all the steel lengths. Okay, there would be 6 total, or there would be 12 total, 4 in each direction. B. If the width of the tank is x, find an expression for the volume of the tank in terms of x and h, the height of the tank. So if the width is x, then the length would be 2x. And so if we wanted to find the volume of the tank, we would have volume equals length times width times height. We know that the length is 2x, the width is 1x, and the height is h. So this is our expression. Now C. Show that L, the total length of the steel frame, oh, they call it L, so why don't we call it L too? We won't call it S. Can be written as L equals 6x plus 450,000 divided by x squared. Okay. Maybe. Okay, so we know that we're gonna rewrite L equals 4L plus 4W plus 4H. We do know that L is equal to 2x, so it's 4 times 2x. We know that W is 1x, so it's 4 times x, and h we just leave as h. So we can write that as 8x plus 4x plus 4h is equal to L, which is equal to 12x plus 4h. Okay, 12x plus 4h. Now, can we relate h to x? Yes, we can, because we have this formula here. V equals 2 times x, 2x times x times h, which happens to equal 225,000 centimeters cubed, right? So let's take this equation, and we're going to relate h to x. The way we do that is we divide both sides by 2x squared. 2x squared. And then, so h is equal to, let's see, 112,500 divided by x squared. So why don't we substitute this in for that h there? So we get length equals 12x plus 4 times 112,500 x squared. Okay? And then, is that close to what we need? Let's just simplify a little bit. So 4 times 112,500 will be 450,000 divided by x squared. Now, is that the answer we were looking for? It is, except they had plus and we got minus. Oh, here. It's plus, isn't it? Okay, we'll fix that. All right. D, find the dimension of the tank that minimize the length of the steel frame. Find also the length of the frame in this case. Okay, so remember, the thing that we're trying to minimize is L. So what if, and we have the quantity we want to get minimized is all in terms of one variable. So if we put this equation in the calculator, then it's going to give us a graph which shows a minimum point, and then we'll just use the minimum function to find the minimum point. So it's 12x plus 450,000, 450, oops, 450, 0, 0, 0, divided by x squared. Okay, and that's going to graph, and then we want to find the minimum length of the steel frame. And we can't see anything here, so we need to maybe zoom fit. Okay, a little hard to see still. I'm going to change negative or x min to like negative 1,000, and then I'm going to change y max to positive 1,000. Now let's graph. I think we need to change the x min to like negative 100, and the y x max to positive 100. Now let's try. There we go. Okay, so it looks like the minimum point in the positive region would be about there. So let's try to find that now. We'll say second calc, minimum 3, left bound, we need to put it about, where is it? I don't see it. Not negative, we want it about a little bit, yeah, there we go, around there. Close to here, right? To the left of this point, because that's the minimum. And then we move a little bit to the right of that point. And then we guess. And the answer is 42.17, comma, 759. 759 is L, which we're trying to minimize. And the left number is X, right? Which is the width, the length would be 2x, right? Did they want to know the dimensions too? Yeah, find the dimensions of the tank and minimize the length of the steel frame, the length of the frame. So we found the length of the frame. It's 759 centimeters. We know x is 42.17. So let's see, length, width times height. So length would be equal to, it's 2x, right? 2x would be equal to 84.34. Width is equal to 1x. So that's just equal to 42.17. And last of all, height. Height we can figure out using one of these equations. This one actually. Height equals 225,000 divided by 2x squared. 225,000 divided by 242.17 squared. So that's, we can do that here on our calculator. Okay, so we put it here, 225,000 divided by 2 times 42.17 squared. So the height is 63.3. Okay, so those are the dimensions of the aquarium. And the minimum steel length is 759. That was about the hardest problem we did.